So I'm on the bottom of page 18, just to read the directions for the next page. It says sketch a graph of a cubic polynomial function with the following roots. So we're going to practice with what these roots and how I would draw them. Now, we have choices. We know if it's a cubic function, the two ends have to go in opposite directions. So we could go like this with our graphs, or we could go in this direction. It's not specified. I'm going to draw them here positive, but in class I know I'll encourage people to kind of try it both ways. So the first one is just our 3 single roots. So I'm going to cross at -4. This can be a sketch, 2, and 5. And we're just kind of drawing in a rough sketch of what this will look like. We don't need to find an equation. We're just making sure we're clear on what the single roots look like. The next one is crosses at -3. And has 2 imaginary roots. Now, I know the way I would probably think of this more, but just in case, I don't know, you're trying to find a way, I'm going to do it the way I said, where it's increasing. It could go like this. That's 1 real root, 2 imaginary roots. Or I could take it down this way, and that would be fine. That's just a decreasing cubic function. Either way is fine, but there's some imaginary stuff going on here, and then it does cross through in one spot. The next one we're going to look at is 0, and also a double root at 5. So it's going to cross through at 0 and have a double root at 5. There's different ways to draw this one. I'm going to draw it this way. Okay, so double root at 5. So there's my 1, 2, 3 real roots because the double root counts twice. The last one is no real roots. So in class, I kind of make you struggle with this a little bit more. But here, if you think about it, if the one arrow has to go down and one arrow has to go up, unless there's a way to break my graph in the middle and not have it go through the middle, there's no way to draw a cubic graph with no real roots or 3 imaginary roots. So not possible for this one. Looking at the next one, now we're going to work on quartic polynomial functions, which are functions that are x to the 4th. So we expect with the fundamental theorem of algebra that we're going to have 4 real roots with these, or not 4 real roots, 4 complex roots. Might be real, might be imaginary, doubles, triples, whatever we see here. So this one, we have a double root at -4, a single root at 0, and a single root at 5. So we know our graph is going to have to either go like this or like this because it's quartic. I'm going to draw this one facing up. So a double root at -4 and single roots at 0 and 5. If I count the double root twice, I do have the 4 roots I expect. Letter B should be pretty simple, okay, because this one just has 4 real roots, all single roots. Okay, so that's what my graph. I could draw it in entirely the opposite direction with both sides going down as well. The next one, a little trickier. I have a triple root at -5 and a single root at -1. So I'm going to start up like I've been. That triple root flattens out and crosses through, and the single root comes back up in this direction. So that would be an example. As I said, I could draw it in the opposite direction too. The next one, we have that situation that wouldn't work with a cubic, but it does work here because the exponent is even. So since both arrows go in the same direction, both facing up or both facing down, there is a way to draw a quartic graph with no real roots, just like we can draw a parabola x² graph with no real roots. I'm actually going to draw this one down just to do it a little differently. Anything you draw, right, that doesn't cross, so that's a way you could draw it down. This is a different answer that would go up. I'm going to stick with the down one for now. Okay, that has as a quartic with no real roots.